Electromagnet by Jordan Fisher and Luna Mendizabal. For our physics final project, we built an electromagnet to learn how electricity can create magnetism. An electromagnet is made by running electric current through a wire wrapped around a metal core like a nail. We tested how changing things like the number of wire coils and the number of batteries affected the magnet's strength. This project helped us better understand how electromagnets work and how they're used in everyday life.
The materials we used: a long iron bolt, enameled copper wire, batteries, a battery holder, sandpaper, and scissors. Why we use these materials: we use copper wire because it carries electricity well. We use an iron bolt because it becomes magnetic when placed in a magnetic field. These materials help make a strong working electromagnet.
Why the bolt and what makes the bolt magnetized? The bolt is made of iron, which is a ferromagnetic material. When the current flows through the coil, it makes a magnetic field. This field causes the tiny magnetic areas inside the bolt to line up, making it magnetized. Here's a step by step of how we made it. First, we wrapped copper enameled wire tightly around a large bolt. Then, we put a battery to two batteries in a battery holder that have a red and black wire attached. Then we use sandpaper to scratch off the ends of the enameled wire that is wrapped around the bolt. And lastly, we wrap the ends of the black and red wires around the ends of the filed copper wire.
How it works: we wrap enameled copper wire around the metal bolt. When the wire is connected to a battery, electric current flows through the wire. This current creates a magnetic field around the wire, which is known as electromagnetism. The magnetic field causes the bolt to become a temporary magnet. When we disconnect the battery, the current stops and the magnetism disappears.
This is a demonstration of Faraday's law. Faraday's law is a changing magnetic field can create or induce an electric current in a wire. How it applies. It's the reverse of electromagnetism. If you move a magnet near a coil, it can create electricity. This is used in generators and also explains how back EMF works in electromagnets.
This also has to do with Lenz's law. What this means is induced current in a conductor due to a changing magnetic field will flow in a direction that opposes the change in the magnetic flux. How it applies: when the electromagnet is turned off, it can create a sudden current in the opposite direction. This is important in designing circuits with electromagnets.
Here it's showing the creating of the magnetic field and what happens when we wrap the coil. When you wrap the wire into a coil, the magnetic fields from each loop add together. This makes the magnetic field stronger and more focused. The more loops and current, the stronger the electromagnet becomes.
Key physics concepts: electromagnetism, the interaction between electricity and magnetism. Moving electric charges, current, create magnetic fields.
Solenoid. A coil of wire, when current passes through it, it creates a magnetic field similar to a bar magnet.
Temporary magnet. The metal bolt is magnetized only when current is flowing.
Right hand rule. A rule used to find the direction of the magnetic field. If you curl your right hand fingers in the direction of a current around the coil, your thumb points in the direction of the magnetic field. A physics principle shown in electromagnets are when electric current flows through a wire, it creates a magnetic field around it. This is called electromagnetism based on Ampere's law.
When the battery sent electric current through the enameled copper wire wrapped around the iron bolt, it created a magnetic field, turning the bolt into an electromagnet. This strong magnet field caused the metal scissors, made of ferromagnetic material, to become temporarily magnetized. The magnet domains inside the scissors aligned with the field, allowing the scissors to act like a magnet. As a result, the scissors were able to attract and pick up the paperclip. This process is called induced magnetism.
How we could have made our magnet better. A way we could have made our magnet better is by using batteries with a higher voltage. This would have made our battery a lot stronger, and also we could have made our battery stronger by wrapping more copper wire and making the coils tighter. Our device compared to ones being used in everyday life. Our electromagnet was simple compared to powerful ones used in everyday life, but it worked using the same basic principles. While ours use a small nail, wire, and batteries, real world electromagnets, like those in junkyard cranes, doorbells, or MRI machines, use stronger materials and much more electricity. Even though our device was small, it helped us understand how the same science powers important machines in the world.
How do they create magnets now? Most magnets today are made by placing magnetic materials in a strong magnetic field. This lines up the atoms inside to stay in one direction. Some magnets are also made by mixing special materials or metals and cooling them in magnetic fields.
Where electromagnets are used and what they're made of. Electromagnets are used in everyday devices. In junkyards, big electromagnets lift cars using strong electric currents, thick copper wire, and large iron cores. Doorbells are used. Doorbells use small electromagnets to move a metal striker and ring the bell. Speakers have coils that create sound by moving with a magnet. In hospitals, MRI machines use powerful electromagnets made with special wire and cool temperatures to scan the body. All of these devices use the same basic parts: a coil of wire, an iron core, and electricity.
Core competency. We use YouTube to watch simple videos that showed step by step how to build one. It helped us understand how the materials work together, like the wire, battery, and bolt. We learned that wrapping the wire around the bolt and connecting it to the battery creates a magnetic field. Without using online tools and research skills, we wouldn't have known how to build it or why it worked.